Hey, what's going on, folks? It's Mike here, and welcome to the programming series in the D programming language. In this lesson, we're going to be looking at how to pass D's static and dynamic arrays as function parameters. Now, we've learned about these different types of arrays in the D programming language previously, so you can check out the playlist before. But before we get into the lesson, I just want to reward one of our members who's been supporting us for over a year right now. So just a quick shout out to Gary, who's celebrating his 1 year anniversary on the channel. He is our first member on the channel supporting us. So just a quick thank you to Gary and all those who have been supporting us throughout this journey on this YouTube channel. Thanks to our members, our subscribers, and viewers. Hope you're getting a lot of value out of the channel. If you want to join us member, feel free to. But as always, I just appreciate your views. And with that said, we'll go ahead and get back to the video. All right, so I hope you enjoyed that, and thank you everyone for the support in the community. It's truly valued. And with that said, let's go ahead and dive into the lesson here. Okay, so I want to go ahead and just bring us to the documentation here. Let's go to the language reference and arrays. Again, you can check out the playlist if you haven't seen some of the other lessons on arrays. Again, there's different types here, static arrays and dynamic arrays we've covered. Pointer arrays are going to be familiar if you're coming from a C programming language. That's just a little pointer to a chunk of memory. We'll talk about that later with things like malloc and allocating our memory, and then associative arrays or dictionaries from other languages. Now, the key thing to know about static and dynamic arrays in the D programming language is, well, we have what's sort of a fat pointer implementation. That's how you can search for it in other languages. But if I just go ahead and click on dynamic arrays here, the key is really this line here. Dynamic arrays consist of a length and a pointer to the array data. Okay, so that gives us an advantage here where if I know the length and I know the pointer of this particular array here, then it makes it a little bit safer, meaning that I can do things like balance checking and so on and compile time by turning on switches, or just in my code without risk of overflow. So I'll go ahead and just illustrate this briefly in this lesson here with an example. But again, if it's useful, you can think of internally having some struct here for anything that's an array. And this is just sort of pseudocode here. And we have our properties associated with that array. So we're going to have a pointer that points to the actual chunk of memory for our actual array, however long that is, a length, and then we have other properties like the size of, for instance. Okay, so let me go ahead and just show those again. If you haven't been following this series, again, in the documentation's super useful for finding these things. So as I'm just scrolling through the dynamic arrays, let's go ahead and scroll till we get to our properties. Again, just to show you here, again, here's our array properties. Here's for our static arrays. Things, again, like knowing the size or the number of arrays. And this could be very, again, useful as you're working with data and might want to know things like the pitch or the stride of your array, again, depending on what type of problems you're working on. But again, usually we want the length and the underlying data. And then, of course, we could do things like duplicate things, and we'll soon talk about immutability in this series. So, of course, make sure you subscribe so you don't miss that. Anyway, so that's the idea here. Again, you're going to see that dynamic array properties also very similar here, and that's what we've got here. So just to illustrate this, I want to go ahead and just show you some code here. And again, if you have some function like printing some data, again, if you're coming from a C background, you have just the pointer to the actual chunk of data here. And then you typically have to pass in the size, for instance. Okay, so this is just a common way of, again, because things in language like C or C++, for instance, you don't have that property built in here, it can make it a little bit, again, more tricky to work with some of these data. Now, in languages like C, even if I pass in, say, an array like this, the array just ends up decaying down to a pointer. And even if you pass in information like this here, like a size, whatever your data is, there aren't strong enforceable guarantees. You can do little things like static, 100 here and try to enforce things. But again, there's no real enforcement here. So anyway, if I'm going to go ahead and write this code here, I might do something like, again, for int, or actually, let's see. So we've got a u long here, the index, I less than the size, I plus plus, and then we would write line, for whatever we want to write here. Okay, so that's just passing in a sort of old school pointer array. Now we still want this in the D programming language, this ability to work with raw pointers, because oftentimes in systems problems or creating data structures, it's nice to have that power. But again, we want to prefer this sort of approach for, again, those benefits of having the length and the size as one parameter here. And again, it makes it still pretty easy to interface with our C code in the D language. Again, we can either do the sort of old C style way, or oftentimes we can convert things, different functions if we need to create an interface in D here. So anyway, this is the idea. Let's go ahead and just finish this function off here for each. Let's just go ahead and say each element in our data, and let's go ahead and write it out here. And let's see, let's go ahead and move things around just a little bit here. Make sure I save. Let me go ahead and give this a run. Let me actually show you what this program is doing. So again, whether I create a dynamic array here, so this first array here, or a fixed size one, again, I still have these properties with my array.pointer. Again, if I just need the underlying pointer and I need to interface with some C function, for example, or I can get the property for the length and again, just pass that in the second property. And again, it's going to be a ulong here. So again, that's all there is to it. And that works the same, again, just showing for a fixed size array or the dynamic array. So again, here's the fixed size where say this is going to be exactly 4 elements. And here's the dynamic size one, which could be, any number of elements. Now, again, for printing in D, again, you'll just notice that for this example, I don't have to pass in size or anything, right? That's built into the actual data structure. And if I use things like a for each loop, for instance, that's implicitly converting to a for loop, which is, structuring something like this, or depending on the data structure, maybe giving us an iterator, for example, for this. So anyway, this is just a quick sort of lesson here to understand what's going on in the D programming language. Again, just reviewing some of the things that we've learned previously in the series. Again, you could just print the particular type here. So again, just showing that we're working with pointers here. Let me actually get rid of this right line because it's kind of annoying. There we are. But just so you can see the type here, and then whether we're working with a static or a dynamic array here, again, doesn't matter. We still get those properties. We still know what the size is, and it still makes things nice and easy to work with. So again, these are some of the things I like about the D programming language, just a little bit safer to program with. We have these properties by default. It is costing us, I suppose, maybe some bounds checking, if you're really a performance, oriented person and you want to be able to eliminate those things, again, you could turn those things off, but we probably want those, these properties like length and so on. Later on, I'll also talk about, some other things in this series about like reserving the memory and resizing and these types of things. But again, if you're going to go through those operations, you don't have to worry about, passing the wrong size into functions. It's just all contained in this data structure and it works really nice. So there you have it. Just want to talk about that. And now we can pass around arrays into our functions. Now, the other thing to just keep in mind here that we've also talked about as a little bit of a review is when we're passing in the dynamic arrays, these are being passed by or arrays themselves. And let's do a little check here. Let's see if we can actually modify that array. Okay, so if I'm passing it in, let's just say data at 0 is now equal to 9999. And then I'm going to come out down later in my code here and just say, okay, my array at 0. Let's see if it gives us that 9999. And it does, right? We're passing things in by reference here. So just another thing to keep in mind when passing around these data types. Again, we've talked about this a little bit. These are reference types by default here, okay? And if you're never sure, just do this little experiment or print out the address of the array as you need. All right, folks. So with that said, that's what we've got for our lesson today. I hope you enjoyed it. Hope you learned something new and hope you feel more comfortable passing things around just using arrays, dynamic or static. And if you are interfacing with a lot of C code or C libraries, again, that's something that D does very nicely. So you don't have to lose the old stuff as well if you're used to passing things around by pointers or need to really interface with a C library. That's really the purpose of this. All right, folks, with that said, thank you for your time and attention, and I'll look forward to seeing you in the next one.